All right, let's get right into it. We're going to talk about what OWASP calls the single biggest security threat for large language models, prompt injection. In this explainer, we're going to deconstruct exactly what that means for us as engineers and builders. Okay, so here's the game plan. We'll start by defining the threat, then peel back the layers to its root architectural flaw. After that, we'll break down the two main attack vectors, and finally, get practical with how to build a real detection and defense strategy.
So let's start with the bottom line. Why should we, as engineers, be paying super close attention to this?
Yeah, you're seeing that right. Number one, this isn't just some minor bug on a long list. OWASP, and we all listen when they talk, has put prompt injection at the very top of their list for LLM vulnerabilities. It is the most critical threat we're facing today.
So what are we actually talking about here? Well, in a nutshell, prompt injection is when an attacker uses clever input to make an LLM ignore your instructions and follow theirs. It's basically a hostile takeover of your application's brain using plain old words.
Now this is where it gets really interesting and, frankly, a little scary. This isn't a bug you can just find and patch. No, this is a vulnerability that's woven into the very fabric of how today's LLMs are built. This slide just nails the root cause. Think about it. In every other kind of software we've ever built, there's a hard line, a firewall, between code and data. But with LLMs, that wall is gone. Your trusted system prompt and some untrusted, potentially malicious, user input, they all get mashed together into one big stream of tokens, and that is the heart of the entire problem. See, the model has no reliable way to tell the difference between your instructions and the attacker's. It just sees a sequence of tokens and tries to predict the next best one. So when an attacker injects their own commands, the LLM isn't malfunctioning. It's actually doing its job perfectly. It's just following the wrong instructions. For those of us who've been in the trenches, the closest thing we can compare this to is good old SQL injection. Untrusted input gets interpreted as a command. But here's the killer difference. With SQL, you can use parameterized queries. You can sanitize the input because SQL has a rigid, predictable grammar. Natural language, it's a completely different beast. It's slippery, it's contextual. Trying to write a filter to sanitize human language is a fool's errand. So let's get into the specifics. The first attack vector is the one you've probably heard the most about, direct injection. This is the classic stuff. You've got jailbreaking, the whole do anything now persona, to get around safety filters. You have prompt leaking. Remember when everyone got Bing to reveal its internal prompt, Sydney? That's direct injection. Or you can just completely hijack the AI's goal for that one conversation. Here, the user is actively trying to break your system. But honestly, direct attacks are just the tip of the iceberg. The one that should really keep us up at night is indirect injection. This is way more insidious because the attack isn't coming from the user, it's hiding in the data. And this is where our whole threat model gets turned on its head. With direct injection, the user is the attacker. Simple. But with indirect, the user is the victim. They're just asking the AI to summarize a web page, but that web page has a poison pill, a hidden prompt waiting inside it. Suddenly, our job isn't about protecting our app from the user, it's about protecting the user from the data they're feeding our app.
This is a textbook, confused deputy problem. The AI agent has legitimate permissions, maybe to read the user's emails, and the attacker tricks the agent into misusing those permissions for malicious purposes. For anyone here with a web security background, this should send a shiver down your spine. Why? Because this completely sidesteps bedrock security principles like the same origin policy. The AI is a trusted intermediary, and it's being turned into a weapon.
And please don't think this is just some academic theory. The Morris second worm was a real-world proof of concept. They built a self-replicating prompt injection attack that could spread through AI email assistants, stealing data and then emailing itself to the user's contacts. We're not talking about a one-off bug anymore. We're talking about autonomous, ecosystem-wide threats.
Okay, so that's the bad news. The attacks are sophisticated and scary. So what do we do about it? How do we even begin to detect this stuff? Well, there's no magic bullet. The only answer is a layered strategy.
A solid detection strategy has to work at every stage. You've got pre-processing, scanning the input before it even gets to the main LLM. Then, in-processing, maybe using a second, smaller LLM as a kind of guard dog to analyze the intent. And finally, and this is critical, post-processing. You have to scan the output, check for leaked canary words, and validate any API or tool call before it gets executed.
All right, this brings us to the most important part for us as builders. How do we actually construct a defense? The mindset here is crucial. We're not aiming for perfection because it's not achievable. We're aiming for resilience through defense and depth.
Let's just get this out of the way. There is no silver bullet. There isn't. Any single defense you put in place can and will eventually be bypassed. So our entire architectural philosophy has to be built around that fact. We have to architect for compromise.
So, if we assume the LLM will be compromised, what do? We limit the blast radius, and that's why the principle of least privilege is by far the most critical control we have. Your AI agent should have the absolute bare minimum permissions it needs to do its job, and nothing more. If your RAG-bot only needs to read documents, for God's sakes, don't give it an API key with write access to your production database.
This table really lays out the roadmap. It's not just one thing. It's hardening your system prompts. It's having those hard architectural controls in place. It's validating every single tool call, and it's an ongoing process. You have to be constantly red teaming your own systems, trying to break them before someone else does.
And let's be realistic, right? The risk isn't the same for every application. A simple public-facing chatbot, the risk is moderate. But an agentic system that's plugged into APIs, that can browse the web, read your email, and act on your behalf, that is the highest risk category by a long shot. The more power you give an agent, the bigger the target on its back.
And that brings us to what's next. So far, we've only been talking about text, but the models are already multimodal. So what happens when the attack isn't in a string of words, but hidden in the pixels of an image? Or encoded in a sound wave? All of our text-based defenses become instantly obsolete. And that leaves us with a really tough question to ponder. How are we supposed to build a defense against an attack we literally can't even see?